We're getting ready to do lesson 5.2, SAT Math Level 1, which is more algebraic advanced methods of algebra. And we got 66 points here on the skill sheet, on the tune-up sheet that follows this lesson here. And there's 38 points here of note-taking that you need to take. Contact me if you need a note-taking guide, or just take your own notes off the PowerPoint or the video. Overview of this section here extends some previously covered algebraic skills related to factors, equations, and more complicated algebraic expressions. Factoring by grouping pairs of terms. You'll see this on your SAT. Some polynomials of 4 terms can be factored by grouping appropriate pairs of terms together and then factoring out a binomial that is common to both terms. So in this example here, ab minus 4b plus 3a minus 12, this can be factored into ab minus 4b plus 3a minus 12. Let's put parentheses around our first 2 terms here and these terms here. So a minus 4 can be extracted out of this situation here by factoring out a 3 of each one. So now you have a minus 4 times b plus 3, which is factoring by grouping now. That'd be one example of that. And then this situation here, you can factor out an x plus 5 from this term here, these 2 terms, and then these 2 terms here, and x plus 5 can be factored out. And then by grouping, you can go x plus 5 times the quantity x squared minus 9, which is a difference of a square, which is x plus 3x minus 3. So that'd be an example there of seeing something right here in this polynomial expression that you can factor out x plus 5. Zeros of a function. A zero of a function is any value of the variable that makes the function evaluate to 0. The zeros of a function correspond to the x-intercepts of the graph function. So, like in this example here, what are the zeros of function f defined by the equation? So we have this situation here, f of x equals this expression here, 2x cubed minus 5x squared minus 8x plus 20. Define the zeros of function f. Find the solutions of the equation where f of x equals 0, meaning when x equals a certain quantity, y would equal 0 on your graph. So again, by starting with these 2 terms here, 2x cubed minus 5x squared plus negative 8x plus 20, let's start there. And then what can we factor out of both of these that is in common would be a 2x minus 5. 2x minus 5, 2x minus 5. Then we get this difference of a square here, x squared 4, by doing the factoring by grouping method. So 2x minus 5 times x squared minus 4, and then we factor this down into this here. So there are 0. Setting each factor equal to 0 yields x equals negative 2 for this one, 2 for this one, 2 is a 0, and then 5 over 2 would be a 0 here. So that'd be the way you do it, or you could put it on a calculator. If it's in your calculator section, you could do it on a calculator. The zeros of the function are these numbers here. The zeros of the function f correspond to the x-intercepts of its graph. So you could graph that and put that on here, and that would be where your polynomial would cross the x-axis. Okay, moving to another example here. F of x equals 3x cubed plus kx squared minus 32x plus 28. We have a little different situation here. It's defined by the equation where k is a non-zero constant. So this is a non-zero constant in the xy plane. The graph of f intersects the x-axis at 3 points, negative 2 and 0. 3 over 2 and 0 and c over 0. What is the value of k? So we have 3 zeros here. We have 2 zeros here. Negative 2, 0 and 3 over 2, 0. And then here are our choices here for k. So knowing that, since the x-intercepts correspond to the factors of a polynomial function, we know that it is x plus 2, 3x minus 2, and x minus c. So this would be the factors of this polynomial. So by knowing that, if the factors of function f are multiplied out, the constant term would be equal to the product of the constant terms in the three factors. So we know that our c is this here, and then these are what we know. We have 2, negative 2, and negative c. So if we solve for c, we'll get 7, won't we? So multiplied factors of those together, c here's our constant here, and then these have to equal 28 here. So we know c has to equal 7. So we plug that back into our original here. We get 3x cubed minus 17x squared minus 32x plus 28 would be that here. X minus 7, then we multiply the two binomials together that we know of, and then x minus 7 here. And then when we get that, we get this polynomial there. So x squared minus term k would equal negative 17 is what k would equal here. Since k is the coefficient of the x squared term, k would equal negative 17. So it will be this would be the correct solution to that question here. The correct choice will be B here. So remainders and factors of polynomials. F of x equals x squared minus x minus 6, then x minus 3 divides evenly into f of x, since if we factor out an x minus 3, we'll get an x plus 2 with a remainder of 0. So also, if f of 3 equals 0, this illustrates that if f of x is divisible by x minus c, c would equal 0. If a polynomial f of x is divided by a binomial of the form x minus c, where c is constant, then the function value of f of c is equal to the remainder. If f of c equals 0, then there is a 0 remainder, so f of x is divisible by x minus c, or equivalently, x minus c is a factor of f of x. This also means that the graph of y equals f of x intersects the x axes at x equals c. If f of c does not equal 0, then f of x is not divisible by x minus c, so it is not a factor of f of x. We should know this. If f of c does not equal 0, then f of x is not divisible by x minus c, so it is not a factor of f of x. And this is the remainder and factor theorems in a nutshell right here. A pretty important entry into your notes. So if x plus 3 is a factor of f of x equals this polynomial here, px squared plus p squared x plus 30, and p is greater than 0, what is the value of p for if we know x plus 3 is a factor? Since x plus 3 equals x minus the negative 3 is a factor of the polynomial, f of negative 3 would equal 0. So if we put that in, we plug that back in, we'll get this here, 9p minus 3p squared. So if we have this equals 0 here, then we can factor out p minus 5 and p plus 2 for this. We take out a 3 here. We end up with this, and then this can be factored down into p minus 5, p plus 2. So p equals 5 or p equals negative 2. Reject, since p's got to be greater than 0. So the value of p is 4. Okay, simplifying complex fractions. A complex fraction is a fraction in which its numerator, denominator, or both contain other fractions. To simplify a complex fraction, multiply its numerator and denominator by the lowest common multiple of all of its denominators. Simplify this situation here, 1 plus 2 over x over 1 minus 4 over x squared. Multiply the numerator and denominator by x squared. This is a situation here that we have to solve. So we multiply numerator and denominator by x squared. So we multiply both these by x squared. This will cancel, and then this will cancel with that. And then we'll have x squared plus 2x, and then x squared minus 4. Now we're a little bit different here, a little bit simpler. We can factor this out to these two binomials, and then these will cancel. And then we end up with this situation here, x over x minus 2. Now, when x to the negative 1 minus 1 is divided by x minus 1, the quotient is what? One of these situations here. So x minus 1 is divided by x minus 1. So to do this here flips our x to 1 over x minus 1 over x minus 1. So to simplify this situation up here, we have to multiply both numerator and denominator by x. We get this now, 1 minus x, these cancel. And then this is a negative x here, so we get 1 minus x over this situation here. And then 1 minus x over x times x minus 1. We factor out a negative 1 out of here. And then we get a negative 1 over x is what we end up with there. Okay, so in our solving of fractional equations, to solve an equation that contains algebraic fractions, clear the equation of its fractions by multiplying each term of the equation by the lowest common multiple of all the denominators. Define a solution to the equation like this example here, 4/3 equals negative 3x minus 13 over 3x plus 5 over 6x for this situation here, solving for x. Multiply both by 6x, the lowest common multiple of all the denominators. So in this situation up here, if we multiply everything by 6x, we have this, the original was a 6x and the 3x's are denominators. So we multiply everything, the whole expression, by 6x. These things cancel, and then we end up with this expression here, 2 minus 3x minus 13 plus 5. It's way more simpler because we've eliminated our denominators, and then we just combine like terms after we do our multiplication here. So we get 8x equals negative 6x minus 26 plus 5. Combine like terms, then we end up finally with x equals negative 3 over 2 for x. So in the equation, what is the value of n squared? So we have a situation here where we have a bunch of denominators here. So eliminate fractional terms by multiplying each term of the equation by 12, the lowest common multiple of all the denominators. So we have to multiply through 12. And when we do that, we eliminate our denominators. We end up with this gnarly thing here that we have to multiply through, distribute multiplication, and then combine like terms after we do that. 3 times 3n plus 1. And then we get this, 4 times 2 times n minus 1. So be 8n minus 8 minus 9n minus 9 equals 6n plus 18. Now we can combine like terms and solve for n. And when we do that, we come up with n equals -5. Take these notes. If you don't know what the heck is going on, review your algebra. Go back into my videos and review solving equations like this in Algebra 1. There's lessons for that, or pre-algebra, actually, there'd be lessons, not in Algebra 2. But this is actually Algebra 1 and pre-algebra. Hence, n squared would equal -5 squared equals 25. So we plug this back into the original, and we get 25 for that. And that is 5.2 of your SAT Math prep. Thank you very much.